Hey guys, welcome to lecture number 6. In this video, you will not see me. I will only be recording the screen. I will not be using the other camera. That's going to be the final lecture for the chapter number 1. Okay, today we'll do some practice with the face, and then on Tuesday we'll start a new chapter. Okay, so let's do some practice exercises from the end of the chapter, page number 11. Okay, so first off, let's do, let's see. 114. Okay, 114. So we need to construct an array that accepts all strings of the alphabet A, B, C. Okay, with A, B, C as a substring. Okay, so technically that's going to be called the language of all strings omega, such that ABC is a substring of omega. Okay, perfect. So let's talk about that. Okay, I guess first off, let's try to come up with a few strings which will be accepted or rejected. Like ABC will be accepted. I don't know, ABBC, that will not be accepted, right? Then ABC, that will be accepted, right? So because that doesn't really matter because we have ABC, the substring. Next, I don't know, ACB, that will be rejected, of course. Now A, B, a lot of C's will be accepted because it has ABC in it. Okay. Empty string will be rejected, right? Because it doesn't have ABC in it. Okay. So just judging by this example, okay, we can see that once we have ABC as a substring, then no matter what kind of symbols we have after that, we definitely accept. And whenever there is a situation like this, that's actually a sign of having in a trap state. In this case, accepting trap state. So let's try to draw that. Okay. Okay, so one state, another state, another state. I don't have any solutions, any clues. I'm just trying to come up with that on the spot. Okay, so A, B, and then another one, C. Okay, perfect. So that's going to be our start state, right? And that's going to be our acceptance state. Okay, cool. So basically what we need to do, we need to count, we need to look for this pattern A, B, C, right? And once we fulfill this pattern, right, then in that case we kind of accept, we succeed, we win, right? So that's why what we can do, we can basically create this pattern like this, right? So from here to here we'll transition on A, then to here on B, then on here on C, and here we accept. A, B, C. Okay, and here we accept. So whatever goes after ABC, we'll definitely accept, which means, again, it is a trap state, which means we're going to loop on all the symbols, A, B, C. Okay, start state is not accepting, this state is accepting, perfect. Okay, now, as you remember, we can't really have, well, first off, don't forget that you need to label them, right? I'm not labeling them right now for the sake of time, but for the homework, please, please, please label them with the capital letters, A, B, C, D, for example. Okay, as I told you before, we need to have all transitions from each state, right? So from here we have only A, sorry, yeah, we only have a transition on A, but what about B, C, right? So what happens if if the string starts with BC, right? Doesn't change anything? No, it doesn't, because then we still need to look for this pattern ABC. So that's why on on BC, we're just going to loop. Okay. Then over here, what do we do? What do we do on B here? So on B, we have a transition over here. On A, what do we do? On A, actually, and that's actually a typical mistake. A lot of times students, what they do, they transition back on to this state on A. Why? Because of course here we have a pattern, and if we have, for example, A and then another A, right? So we kind of start the pattern again, which is not really true. Okay, so what we need to do here on A, we need to loop. We need to loop. Okay, so here's why. If I have a string, let's say AABC, okay, so on A I'll go over here, and then on one more A I'll loop, right? And if I have a couple of more A's, I also need to be in this state, because then I'll be looking for B and C to accept, right? So I can't really go back over here. If I go from this state on this to this state on A, in this case I'm going to have A, and then B, C, I'll be looping here, so I'll be rejecting. So that's not possible. Cool. Okay, now what do I do on C here? Okay, so if I have A and then C, what do? I need to kind of restart the whole pattern. So I need to come back to this state and then look for A again. Wait for A, look for A. Okay, so I'll come here. Perfect. Now what I do here over here? So if I have A, B, C, and then I accept. If I have A, B, and then what if I have let's say A, B, and then A? What do I do? Right? It's, for example, if I have A, B, A, B, C. Okay, A, B, and then A, B, C. So I need to accept this string, right? Which means that on A from here I need to come over here on A again to this state and then continue looking for B, C. So that's why I'm going to come here on A. Moving on. Yeah, so A, B, C. Okay, perfect. Now, next, what do we do from this state on B? Okay, so for example, if we have A, B, right, and then B, okay. So in this case, we already broke the pattern completely. So we need to start all over again looking for A, right? So we need to start all over looking for A, B, C. So only like that, only this way we can make it accepting, which means we basically need to come back to the start state on what? On B. Okay. Perfect. And on here, in this state, we just loop on ABC. Okay. Yeah, and that's it. That's it. So again, this will be accepting. A, B, B, C, A, B, B, C. This will be rejecting. A, C, B, A, C, B. This is rejecting. A, B, C, and then a lot of C's. Okay, that's accepting. Empty string is rejecting. Cool. Perfect. Okay, hope it makes sense. That's one. Then number two. Yeah, 116. Like this one a lot. Like this one a lot. So we need to construct an array that accepts all strings of A, B, C as well, right? With letters going in alphabetical order. Okay. Now I'm going to describe that formally. Alphabetical order, right? So this the characters there need to go in alphabetical order. Okay, let's think. Let's come up with a couple of examples. So ABC should be accepted, of course, accepted. And then a lot of BC, okay, that will be accepting. A lot of A's, BC, that will be accepting. A lot of C is accepting. Okay, and that's actually what usually students come up with immediately. However, keep in mind that we don't necessarily need to have all the characters. It's possible to have some of them, right? Or we can completely omit some of them. But it's possible that it was still in the alphabetical order. For example, I can have two A's, right? That's still alphabetical order. I can have BC, right? I can have CC. I can have AC, right? I can have AC, AB, okay? I can't have something like BA, CA, cannot have that. I can't have, for example, A, B, 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 C, and then B. Cannot have that, right? Because I screwed up pattern. Hope it makes sense. Okay, so it's kind of similar. We still have this pattern like where we go from left to right on A, B, C, and accept somewhere on the right, right? Well, no. We immediately accept from the very beginning, actually. So let's see. Yeah, it's actually kind of a similar pattern. So let's. Okay, hold on. Okay, perfect. So let me erase this. Okay, okay. Yeah. Okay, let's make it this way. Okay, so what do we have here? A, B, C. Okay, then we'll accept it. Okay, perfect. Now, so think about this. What if I have a string which will be like, let's say, A, B, A, and then, for example, a lot of A's. Okay, B, C. Okay. So once we see a small discrepancy, right? A tiny discrepancy, like a BA, right? That's already not alphabetical order. What does that mean? That means in that immediately, in that particular moment, we know that we're going to reject, right? No matter what we have after that, that's already not alphabetical order. And whenever we have a kind of a rationale way of thinking, we immediately should understand that it's going to we're going to have a trap state, reject and trap state. Okay, so in that case, am I recording? Recording. Okay, so in that case, we're going to create a trap state, reject and trap state. Okay, I'm going to loop on what? On all symbols, right? Because it's trap state. Okay, so what do we do? So for example, if we have A, B, so from this state, right? If we see A, what do? We go to trap state. Okay. If we see A, then B, right? And then after, no, hold on. A, oh no, sorry, no. Here, okay. If we see A, B, okay. After B, if we see A, that we're going to reject. And over here, after C, if we see A or B, we're going to reject as well. Okay, on the trap state. Perfect. Moving on. What happens? I don't think we need a loop here. Okay. Okay, so let's think about accepting states. Accepting states. Is this state accepted? So the empty string, is that accepted? The answer is yes, because the empty string has alphabetical order. So there is nothing which would violate alphabetical order, and the empty string is one of it, is an example, right? So that's why empty string is going to accept. Then this, just A, is that going to be accepted? Yes, because A, just A is alphabetical order. If I have AB, is that accepted? Yes. If I have ABC, that's also accepted. Okay. Now let's think about this. ABC. Okay, for this state, if we go to trap state on AB, what do we do on C, right? If we have ABC on C, we're just gonna loop because we're still going to accept, right? Okay. Now, for this state, what should we do on B? Okay, it's a very good question. So if the first symbol we see is immediately B, for example, B, a lot of C's, okay, what does that mean? That means we skip A, okay, which means we skip this state. We immediately need to go over here. Okay, that's why we're gonna go over here, and we're gonna go there on B. Okay. Same thing with C. So what if our string is just a lot of C's? What should we do? We would also skip A, skip B completely, and we would just need to go over here to the last state. So we'll just go to this state, and that'll be on C. Okay. Next, what about this state? On B, we go to here, which makes sense. On C, we need to skip B and go here immediately. Okay, I'm gonna draw it here because it's the same transition. almost. Okay. What if we have? What if we see A? Okay, so if we see A first and then we see one more A, or a couple of more A's, then we'll probably loop, right? Because that is still alphabetical order. Everything can still go right or can go wrong. So that's why I'm going to loop here on A. So what should I do here? On A, I go to trap state. On C, I go over here. What should I do on B? So if I have A, B, then a couple of more B's, B, 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 and then C. So that should be a loop. Okay, so we'll loop here on B. Okay, perfect. Yeah, that sounds like that's it, actually. I think that's it. I hope it's correct. I hope it's correct. I don't know. Okay, next. Yeah. Okay, let's finish. Yeah. Next will be. Yeah, 118. Okay, so in 118 we basically need to explain what does this FA accept. Okay, so it's kind of the opposite. We're given an FA and we need to explain what does it do. So that FA has 4 states. Okay, so this one is the start state. Okay, yeah, from yeah, like this. Okay, and it accepts all binary strings. Hold on, and the last one is accepting. This guy is accepting. So we have the alphabet is 0, 1. Okay, so here we go 0. That's 1. From top to bottom, we go 1. Here we go 0. That's our 0, and that's our 1. Oh, awesome. And this guy loops on 0, 1. Cool. Yeah. So our assignment is to understand what does it do? What kind of strings does it accept? Okay. So there are a couple of ways of doing this. The first one would be kind of think about, especially in this case, you see kind of, so what do you need to have in the string in order to achieve success, in order to get to the state? Okay, so let's think. Um, What do I need to have? Like 0 from here, 1 from here. Okay, so let's think about physical meaning of each state. Okay, so this doesn't mean much. This guy, what does that mean? That means the last symbol we saw, right, was 0, because the only way to get to the state is either this arrow or this transition, right? 0 in both cases. What about this guy? If we are in this state, that means the last symbol we saw was 1, because the only way to get here is from this transition or this transition. Okay, and after that, if we see 1, then we'll go here and accept immediately. Okay, so the fact that we have a trap state which accepts means that they're looking for some kind of condition, and once that condition is satisfied, no matter what you have afterwards, you'll definitely accept. Okay. Same thing over here. So if we're here, we saw the last symbol we saw was 0, and then if we see one more 0, we'll accept. Okay. I hope at this point you can guess what kind of pattern there is. If you can't, what I would also recommend is just to write out a bunch of different strings. Okay, just write them out and think about which ones of them accepted and which ones are rejected. So just completely random strings: 0, 1, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0, 1, 0, 1, 0. Okay. So just think about let's think about this. How about 0, 1, 0, 1, 0? So 0, 1, 0, 1, 0. Okay, rejected. Okay. What about this? 0, 0, 1, 1. Okay. What about this? 0. Okay. What about just 1? Okay, not enough, right? Then a bunch of zeros, bunch of ones. Bunch of zeros already accepted, and 1, 0, 1, 0, 1, 0. So 1, 0, 1, 0, 1, 0. Okay. So at that point again, you should probably guess that this string accepts all binary. This FA accepts all binary strings with double 0 or double 1. Hope it makes sense. Okay, next, by the way, I saw a variation of the same problem which was saying that we need to draw an FA which accepts all strings with 0, 0, and 1, 1, but not a substring, right? Because that is a substring. We need to accept all the strings with 0, 0, yeah, which would which would end with 0, 0, and 1, 1. Okay, so that would be FA accepting all binary strings ending on 0, 0 or 1, 1. Cool. Okay, so that's actually kind of similar, right? So let's think about the difference. So if before, again, once we saw 0, 0, we immediately knew that we need to accept, right? No matter what we had after. In this case, in the new FA, that's kind of not enough. We need to finish up on 0, 0 or 1, 1, okay? So if we see 0, 0, we still not ready to accept because we need to process the rest of the string. And then if we see 1, okay, so then we should reject. Which means that we don't really have that condition anymore when there is some sort of criteria, we hit the criteria, we accept, right? Which means that we're not going to have a trap state. Okay, so let's think what we need to change in this position. What do we need to change? So this part is going to be the same, like these three states, this guy also, but definitely not going to have a loop. Okay, and now check this out. So what does this state mean, right? That means the last two symbols we saw were either 0, 0 or 1, 1, right? And we should probably loop on something, right? So if the last two symbols we saw were 0, 0, we should loop on zeros. If the last two symbols were 1, 1, we should loop on ones. But we cannot know what those two symbols were, right? Because we have one state only. So one state is not enough to remember that. That's why we need to split that into two states. Okay, so we're gonna go over here, and accept, right? Because they're both accepting. That is still the same state, but just split. 0 is going to be this, 1 is going to be this. Okay, perfect. So now for this state, we should loop on 1, right? Because the last two symbols we saw were ones, and we just can add a couple more ones. For this guy over here, we can loop on 0 because the last two symbols were zeros, and we can add a couple of more. But what happens for this guy, for example, if we see 0, for example, 1, 1, 0, okay? We need to go to some state and wait for one more 0, right? Which means we need to go to this state. Okay. And same thing over here. So what if from this state I see 1, right? That means that it's possible that we're going to have one more 1 and then accept, which means we need to go over here. And that's it. I think that's it. That's the answer for this exercise. Okay. One last thing. For the homework, you guys are going to solve the problem, which is 117. Okay. So that says you need to construct an FA accepting all binary strings with even number of what zeros and not odd, and ones should be multiple of 3, right? So basically 0, 3, 6, 9, 12, and so on. Okay, so let's think about let's come up with a couple of strings. Okay, so 0, 0, 1, 1, 1. Okay, so that should be accepted. 1, 1, 1, 0, 0. That should be accepted. Now also, let's say 6 ones, 0, 0. That should be accepted, right? But also, if I have 1, 1, 1, Okay, that should also be accepted. Why? Because I have 0 zeros, and 0 is still number of is still an even number, right? So if I have a string without any zeros, that would still work. If I have 0 0, that would also still be accepted because I have no ones, and 0 ones is still a multiple of 3, so that should be good. Okay. Uh, yeah, so just wanted to give you a hint with this. Not gonna spoil the whole fun, but okay. So whenever FA says something like this, please draw an FA which accepts this and this. Kind of you have two conditions. The best way, the easiest way to approach such tasks is to draw two separate FAs. For this, right, kind of imagine that this doesn't exist, second part doesn't exist. And for this, imagine that this part doesn't exist. Okay, so let's do that. Let's try to draw an FA with even number of zeros. Even number of zeros. Okay, we already did that, I think. Chic, chic, and then chic. Even number, that means we accept an 0 number as a number, right? So that's going to be number of zeros, right? 0 0. Okay. 1 1. Okay. 0 0 1 1. Perfect. Yeah. So if we have just a 0, that we accept it. If we have 1 0, second 0, we accept it. If we have 3 zeros, we're rejecting. And just whenever we have ones, we don't do anything because it doesn't matter. Okay, so that's one. Number two, where number of ones is a multiple of 3. Pretty much exactly the same thing, but with 3. Okay, so even means multiple of 2, and multiple of 3 is going to look very similar. Okay, also empty string is accepted. Okay, so 1 1, right? And now we're going to go over here on 1. Okay, same thing with looping on 0. Not even going to label those errors, those are zeros. Okay, hope it makes sense. Yeah, so now we have them, right? And now we need to combine them together. And whenever it says and, okay, so that usually means that we need to kind of multiply them by each other, okay? Not sure if it makes sense, but basically what's going to happen is we're going to have kind of one axis, another axis, and then we're going to have to create a table, basically in this case 3 by 2. So we're going to have like an FA, which is going to look like this, and only this guy I think will be accepted, and that's going to be a start state. Okay, so that's kind of a hint for you. So you're going to have, in that final FA, you're going to have 6 states, right? And how to draw transitions between them. That's really, think about how you can combine this guy and this guy such that only when both of them are only when both of them accept, you accept. Okay, and if one of them accepts, let's say this guy, but this one doesn't accept, you reject. Okay. Yeah, hope it helps. That's it for today. Please submit the notes. Homework is due on Monday. It will be on FAs. I'll see you guys later. Bye bye.